We've been wanting to do something unusual and big for a long time. And of course, we don't have the money for full-blown documentaries and big research. But we have the desire to show you something unusual, and today we are going to do it. We set an ambitious task to tell the whole history of the planet in 30 minutes, dividing the video into two parts. This is, of course, an infinitesimal amount of time for details, but it's just enough time to brush up on your knowledge and get to know some very interesting facts about Earth's history that usually don't make it into textbooks. After all, our planet is not just made up of people. Our world has had billions of years to change beyond recognition, and whole ecosystems have died out one after another. Right now we are going to summarize everything that has happened in the last 5 billion years. And in the comments, we are very much looking forward to your assessments and opinions on whether we should make such big videos in the future. Well, our journey starts about 4.5 billion years ago. This is not so far away from the Big Bang that created the universe. It happened 14 billion years ago, so the Earth is only 3 times younger. So is the Sun, which formed almost simultaneously with our planet. By cosmic standards, of course, because 10 million years is nothing to them. If you imagine the age of the entire solar system in 24 hours, it turns out that our Earth was formed by the concentration of cosmic dust in just 1.5 minutes. Now, in general, the Sun and the Earth are considered by scientists to be young formations. Critically, it is important to realize the main point: this is indeed scientific data. Now conspiracy theories are in vogue, and on the internet you can find entire pseudo-scientific works with alleged refutations of the real age of the universe and planet Earth. Alleged magnetic fields, oil deposits, and dust layers on the moon do not add up. There is even a popular book called Creation that collects 107 such proofs. And the funniest thing of all is that one of the arguments is the drumbeat of the Bible, which says that God created us several thousand years ago. We have nothing against the Bible. It is a priceless record of the past, but to call it strictly scientific is definitely not possible. After all, in Australia, in the Jack Hills area, they found zircon crystals that are 4.4 billion years old, and calcium from meteorites. Radiocarbon analysis dated even older dates. It is important to note that such analysis cannot physically lie. All radioactive isotopes decay at the same rate, and a trivial calculation of the number of decay products gives a clear estimate of the age of the object. So at least our planet and the system as a whole is no younger than these dates, and maybe even older. Well, Earth's history began in a protoplanetary disk, a region of gas around a star. Gravity and physics inexorably forced matter to shrink, and the sun that formed at its center heated it, melting it, while sweeping away the lighter elements and keeping the heavier ones close. Thus the first 4 planets proved to be harder, and the gas giants formed on the shutters. The Earth, like Mercury, Venus, and Mars, was originally a hot and in some places liquid ball under constant bombardment from space. This is again proven by radiocarbon analysis. The amount of lead isotopes in the rocks of the planets and the meteorites is actually the same, which means that they were formed almost simultaneously from the same substance. At that time, meteorites were much more numerous, and when they hit the Earth, they not only heated it but also increased its mass, saturating the planet with iron and nickel. And then, just a few million years after the balloon formed, our planet was put to a terrible test. Another young planet the size and weight of Mars slammed into it. It's called Thea, and it took a hell of a beating. As the Earth began to cool, the moon was formed from the shattered fragments. Scientists disagree about Thea. Some think it went off at a tangent, others think the cores fused together. But the main thing for us is that the moon is definitely a fragment, according to its compositional data, because it is made of terrestrial material. The satellite was much closer, only a few tens of thousands of kilometers away. The view was excellent, and at the same time the collision tilted the orbit of our planet, slowing it down a bit. We go back about 4 billion years, by which time the Earth had already moved away from the collision. What's more, the nickel and iron have finally settled into the core, and the surface has cooled down. Each of the meteorites that hit the planet carried a few drops of water. Now imagine that this process continued for tens of millions of years. All the drops were taken away by the gravity of the merciless core, and the Earth became a ball of water, more like a planet from Interstellar with huge waves. because the temperature then reached 100 degrees and it rotated much faster. Throw in a tightly orbiting moon and you get terrible hurricanes and tsunamis. In addition, the volcanoes did not disappear, adding to the disco with the eruptions of magma. But despite all this, the first life appeared there, plus or minus 4 billion years ago. Scientists don't know how, and if they did, we'd be immortal gods. But everyone agrees that a confluence of factors in the form of volcanoes, meteorites containing proteins and amino acids, and warm water was to blame. In some unfathomable way, the emissions from the hot springs gave rise to the first single-celled bacteria. There are a number of hypotheses, some of which say that life existed even in the protoplanetary cloud, and that there were living things on Earth before the appearance of bacteria. It's just that the evidence of their existence has not reached us, officially. The oldest fossils found are dated at 3.7 billion years old, and they were found in Greenland. But in Canada in 2017, they found something lifelike with an age of 4.28 billion years. All in all, it's not good with exact dates because of the antiquity, but it's great for understanding how life evolved. About 3.5 billion years ago, the simplest single-celled bacteria evolved into stromatolites, which you can still see today if you look at pebbles and shallow ocean water. They're not actually pebbles, but whole communities of bacteria that feed on sunlight and water. The process creates glucose, and the byproduct of the bacteria's food is oxygen, which they don't really need, which these rocks have been filling the planet with for millions of years, starting a chain that will lead to the emergence of highly evolved life. But that would have to wait almost 1 billion years. And first, huge amounts of oxygen led to the total glaciation of the Earth. The atmosphere used to be mostly methane, which caused the greenhouse effect. When it combined with oxygen, it turned into carbon dioxide and water. At the same time, the sun was not yet so strong, and the Earth entered the so-called Huronian glaciation. It wasn't until 2 billion years ago that the first living things with nuclei in their cells began to use oxygen for metabolism, and about 1.7 billion years ago, the first multicellular organisms did the same. As you can see, this didn't even happen in the first half of the planet's existence. The first algae had to wait even longer, arriving about 1 to 100 million years ago. At the same time, the appearance of the planet changed. Before that, you could see islets and land breaking through. The Earth's core had no plans to cool down and split the crust into lithospheric plates that floated on magma, rising and falling. About 1 billion years ago, the first supercontinent, Rodinia, formed. Some scientists think it's actually the third, and the plates have docked before, but Rodinia is well studied. It existed when the day lasted 17 hours and there was nothing more complex than algae on Earth. The land was trivial chunks of rock. Future India was quietly neighboring Antarctica. Part of Africa was dangling as an island, and the other was merged with South America. But what is the saddest? The core, in addition to the formation of land, gave birth to dozens of volcanoes. Their eruptions led to the formation of acid rain. New continents blocked the flow and the Earth slowly froze. There is even a theory that somewhere around the turn of 1 billion years ago, it was completely covered in snow, reflecting all the sunlight back and freezing. But since volcanism is a cyclical process, eventually the snowpack began to sink, and glaciation was replaced by global warming. In fact, this is how the Earth has moved throughout its history, alternating between cold and hot periods. And as for our glaciation, about 750 million years ago, it melted and released all the frozen oxygen from the oceans and glaciers. This caused an explosion that was reflected in the animal kingdom. The event is called the Cambrian explosion and is characterized by the fact that scientists suddenly find in fossils 540 million years old whole outbreaks of living creatures with complex organization. More recent studies attribute this to the fact that the Earth released a lot of oxygen as it grew, and the process actually began somewhere around 750 million years ago. As the amount of oxygen increased, so did the size of the animals, most of which still lived underwater. The continent of Rodinia split into Gondwana and Lavrasio. Temperatures rose to 30 degrees. But the land is still covered with algae at best. It was all about solar radiation scorching the planet, but rising oxygen levels also helped, creating an ozone layer. And somewhere around 570 million years ago, during the Cambrian explosion, the first forests, ferns, and a whole bunch of vegetation appeared on the planet. At the same time, the land attracted the attention of lizard-like amphibians. These were temporary visitors to Earth at first, as they were still able to live underwater. From that point on, evolution accelerated, and 300 million years ago, when the continents reunited to form a single Pangea, the Earth looked like a tropical paradise, populated by giant insects, the ancestors of dinosaurs, and trees as tall as 100 feet. You haven't forgotten the high oxygen content, have you? It was almost 35% of the atmosphere back then. And to speak boldly about gigantism, scientists allow coal because it is the ancient evidence of life, where the corpses of animals and plants settled in swamps, forming minerals that we use to this day. In fact, that's why it's called the Carboniferous period. Somewhere around here, 300 million years ago, the continents reunited to form a single Pangea. At the places of their collision, mountain systems were formed, and this is how, for example, the Ural Mountains, which were much higher at that time, appeared on the planet. And in case anyone is interested, the Ural Mountains, as well as the Appalachian Mountains, are much older than the Himalayas with their Everest, and by that time, life was in full swing. There were insects running around the planet, a lot of vertebrates that looked like Varanoid gorgonops, and on the territory of Russia, shell-covered scutosaurs were breeding massively. But all of them, about 253 million years ago, were waiting for a terrible fate, the Great Permian Extinction. In general, due to the constant merry-go-round of icing, volcanism and global warming, there have been many mass extinctions on Earth. Huge ones stand out as many as 5. But the Permian is unsurpassed in history for both lethality and mystery. Sometime in 50,000 years, 96% of aquatic species and 70% of terrestrial species disappeared. The most likely cause is increased volcanic activity in Siberia. It is believed that numerous eruptions covered the planet with a layer of dust, resulting in less sunlight, more methane, and everyone either suffocating or banally starving to death. But there is also a 500-kilometer crater near Wilkins Land that indicates a collision with a huge meteorite that occurred more or less around that time. Adding to the horror of the situation is the fact that even insects, which are known to be much more survivable than other individuals, have become extinct. It could take up to 30 million years for the biosphere to recover from the Permian extinction. But, as they say, there is good without good, for the devastated Earth was filled with archosaurs, descended from a tiny number of reptiles that miraculously survived the extinction. Somewhere around 230 million years ago, the same giant guys we love to see in movies today entered the arena. To understand the size of their era, consider that they lived on the planet 50 times longer than humans. And that's if you count our time from the very first humanoid ape. 200 million years ago, they finally established dominance over the planet, which will end only 66 million years ago with the next Cretaceous-Paleogene extinction. But there are a few things that don't usually make it into the textbooks. First, dinosaurs didn't die out anywhere. Modern birds are part of the order Therapsida, and long ago scientists openly referred to them as feathered dinosaurs. And all tyrannosaurs and diplodocus have the scientific name non-bird dinosaurs. And only they are extinct, because the modern chicken can be considered a very distant, but still a descendant of dinosaurs, which, by the way, also had feathers, as modern reconstructions show. Well, the second fun fact is about crocodiles. It is often said that they are older than the dinosaurs, but this is only half true, because the crocodile family appeared almost simultaneously with the dinosaurs, about 240 million years ago. But they were very different guys. They were big, and they ate even 9-meter dinosaurs calmly, dragging them into the water. When there will be 100 likes under this video, we will release part 2. See you soon.